this is for you. So our co-founder and CEO, Deeps, will be running you through the literal cost analysis of accessing LLMs and building agents unchecked and how this can be worked upon and the costs managed by implementing steps within your team. To give you an overview, Console is a plug-and-play security harness built by ClearTrust that focuses on security and cost protection when it comes to AI safety. The agenda of this call will be a 35-minute presentation and educational webinar that will help you navigate this overhead costs and overall challenges when it comes to LLM safety, and will end with a Q&A. Over to you, Deeps.
Yeah, thanks, Ankita. Welcome, everyone, and thank you for joining today's session. The title for today's session is Taming Runaway AI Spending. So let me start with a situation that may sound familiar to you. Your AI bill doubled last quarter. Finance is asking why. Engineering is not fully sure. And you cannot clearly tell which team caused the increase because everybody's into it. Everybody is either vibe coding or either building apps or building agents or kind of inducting them into their workflows, maybe using N8N, using Zapier. So which model costed you, which application generated the most traffic, or even which prompt triggered the spike? And while everybody is trying to see how did the last month's bill spike or what happened to the last month's bill, your engineers by that time have already shipped 3 more AI features and maybe a few more agents into production. This is the exact challenge we are talking about today. When you guys are all aware of AI, I'm very sure about it. And you can see that the innovation is moving very incredibly fast, but the cost visibility has not kept up. Now, if you draw a parallel, in traditional cloud infrastructure, we eventually learned how to monitor servers, storage, databases, compute. But with AI, the cost unit is different. The cost unit is often a token, and tokens are much harder to see, attribute, and control. So in today's webinar, in the slides which follow, we'll talk about how teams can get full visibility, apply granular governance, because governance is a very key factor in when you are using AI or building apps or building agents, and control AI spend without slowing the teams down, because the teams have to work with their own pace because there are certain workflows to deliver. The goal is not to block AI adoption. The goal is to make the spend understandable, manageable, and predictable. So before we get into solutions, let's first understand in the next slide why this problem is bigger than most teams realize. The problem is bigger than you think. The problem with AI spending is not just that the usage is increasing. The bigger issue is about the view from where the usage is coming. As I said, it's all priced by tokens. And tokens are actually invisible to most business and engineering leaders. You don't see the tokens the same way you see a server running or a database or a SaaS license being added. They are generated inside prompts, system instructions, your conversation history, your retrieved documents, tool flows. And with agentic AI, this becomes even more serious. A normal chatbot may respond once to a user, but an agent can make multiple tool calls. It can search documents, it can retry tasks, and it can do, you might have heard of loop engineering, it can do looping if it is not properly controlled. Now this agent, as you understand, talks to the LLMs to get the LLM is the brain. So the agent talks to the LLM to get instructions on what to do next. This means one bad workflow, one misconfigured agent, or maybe one unmonitored API can burn through a large amount of money before anyone even realizes or notices. The data here actually makes the point very clearly. Many organizations actually still don't have comprehensive monitoring of AI data flows, and you might be using multiple models there. Now, high-risk organizations are seeing thousands of AI-powered incidents per month, and the average cost per incident can be extremely high. Now, but the most important sentence on this slide, most engineering teams have zero visibility into who's spending what on which model and for which task, the core problem. If you cannot answer these questions, you cannot govern AI spend. You're not managing the cost, you're actually just receiving the bill afterwards. To understand why this happens, you need to look at the basic economics between LLMs, what we call the token economy, in the next slide. So why AI costs spiral the token economy? Now AI costs spiral because of how LLM pricing works. Now you know that, right? There are different types of models also. They come in nano, mini versions also, and then there is a premium model as well. Every time you make a call to a LLM, large language model, you pay for input tokens and output tokens both. Input tokens are everything you send to the model, and output tokens are basically the model generates back and responds back to you. So the total cost is what you pay, and every model has a different per million pricing for the input tokens and per million pricing for the output tokens. At first, teams usually think that the user message is the main cost, that whatever you are writing to the LLM is the cost. For example, someone asks, summarize this ticket, or maybe draft an email response, or classify this document. The user message may be small, but the real cost comes from everything around that message. Your system prompt counts, your developer instructions, they count, your conversation history counts. And if you are having a RAG at the backend, which is basically a vector database, your RAG chunks also count, retrieved documents count, tool outputs count. And if there are any examples, like long examples inside the prompt, that typically when people write prompts for LLM, they might want to give it references. So they'll say, okay, refer this URL, or everything counts there. Long examples count. Even instructions, if you repeat again and again also on every call, they also count. Now, in your team, there could be different types of users who are using this. Everybody has their own way of prompting. There is no standard way of prompting. So everybody has their own way of engaging with the LLM. So somebody might be very elaborate, somebody might be very concise. So the costs start varying, which is not in direct control. Now a team may think that, okay, we made only a few thousand requests, but each request is carrying a large amount of hidden context. And now replace the human conversation with agents. Right? When the agents enter the picture, the cost multiplies further. An agent does not make only one request. It will do a tool calling. As I said, it will observe the result. And if it is not happy with the result, it will reason again. It will call another tool. It will summarize, retry, continue, till it tries to give you the best answer, or it tries to accomplish the goal which it has been given in the workflow. So when we are talking about AI cost control, we are actually talking about controlling the full token lifecycle. What is sent, what is generated, how often it happens, and whether it was necessary in the first place. I mean, you can say tokens are the new cloud compute, except they are much harder to see. Now, in the next slide, the fourth one, we'll discuss what are the biggest reasons why token usage grows so quickly, and is the context window bloat. Now, context window bloat is one of the most common reasons AI builds grow faster than expected. As I mentioned, right, you can have a conversation and you are trying to achieve a goal with the LLM in that conversation, or the agent is trying to achieve a goal. Every chat you are having, or every conversation which the agent is having with the LLM, is building the context so that you can get more relevant answers. Now, this window can bloat. In many AI applications, you can see every new message sends the full conversation history back to the model. It means the model is not just reading the latest user message, it's actually reading the entire thread again and again. So if you have for example, a 10 conversation, it is not 10 interactions. Every turn can become more expensive than the previous one because the context is always growing. Now, turn 1 can be cheaper. Turn 2 includes turn 1. Turn 3 includes all the turns. By the time you are at 10, your model has received the entire conversation thread. And this gets worse with agents, as I said. It could be, and if you have vibe coded, I'm sure some of you might have that. You can always plan before you execute. So when you plan, there is a plan MD file which gets created, which has the entire context. Now agents can carry forward plans, observations, intermediate outputs, tool results, reasoning steps. A single agent action actually can end up sending tens and thousands of tokens. Now, one thing which I'll say very important to remember is that more context does not always mean better output. Sometimes more context just means more cost, more latency, and more noise. A well-designed system, if you are creating or building, or a workflow you're building, it's about sending the right context, not all the context. It should summarize the older terms, retrieve only the most relevant documents, and basically set hard limits on how much context can be sent in a single request. Without that discipline, context becomes a tax for you, and you pay on every single call. Now, context bloat, as I said, is expensive, but agentic loops can be even more dangerous because they can keep spending automatically. In the next slide, we discuss agentic loops with no circuit breaker. This is where the agentic AI changes the risk profile. Now, traditional AI applications respond to a user request, one input, one output. Take actions. They can search data, they can retry, they can create plans. Now, this is powerful. What you're trying to achieve is powerful because you have kind of outsourced everything to the agent. You have defined a goal for it, it is achieving it, but it is also including a cost risk. Now, the first thing, the agent can be misconfigured. It can get stuck in a loop. Now, whenever you wipe code an agent or whenever you build an agent and give it a workflow, you don't, nobody now would go and review the entire code on how the agent is written or the functionality. So there could be, if there is a slight misconfiguration in the agent, it can get stuck in a loop. It may call the same tool again and again. It may try to complete a task that has no valid end state. And it can repeatedly ask the model to reason about the same problem without reaching a conclusion. So it can keep asking the same thing because somehow it's misconfigured. Now, and for you, now this is happening invisibly to you. You have actually set up the agent and said start. Now, each of the steps is costing money. The scary part, this can happen very quickly. I'm not sure if some of you might have run ad campaigns earlier. I'm just trying to draw a parallel that in ad campaigns, you set up a budget, whether it is LinkedIn ads or Google ads or Meta ads. You set up a budget and you say that, okay, this is the budget. Now, there is a choice for you to set a limit on the budget, or there is a choice for you to allow Google to decide what is best for it in terms of spending. It can overrun your budget. It can spend anything you want. And you will not even know, and the bill could come at $10,000, $20,000 at the end of it for a campaign. Similarly, a runaway agent does not wait for the next monthly billing cycle. It will create a 4-figure bill before the next stand-up meeting. That is why agentic systems mandatorily need circuit breakers. Now, circuit breaker, as you understand, it is basically a control that stops the system from before the damage gets too large. For agents, it means like setting limits for maximum tokens per run. What are you allowed for? Maximum tool calls, loop detection, approval thresholds, and automatic halt conditions. You want to give autonomy, which is valuable, I agree. But I mean, without boundaries, it becomes risky. And the number of agents is not one. I mean, you might have heard the example of Salesforce. Right? Salesforce has deployed more than, I think, 10,000 agents, which are working. Every production agent should have a budget, a boundary, and a kill switch. The kill switch should be with the human in the loop. You need to have control of the kill switch. Now, even when agents are working correctly, teams can still overspend. This we'll discuss in the next slide. If they're using the wrong model for the job, there's another way, model mismatching. Now, model mismatching is one of the easiest ways to waste money in AI systems. Many teams actually default to the most powerful model for anything. So if you want to write an email, you might go to Cloud Opus, D4O, or any other premium model, or for tasks that may not require that kind of reasoning. But for every task, I mean, every model is not appropriate. You don't need the smartest model for every task. If you're just classifying support tickets or maybe extracting fields from your documents, summarizing or doing sentiment analysis, or just simple yes or no questions, a smaller and cheaper model will be more than enough. Some of you might be already doing it and using it that way. But it's a very subtle and an important factor because the difference in the cost can be dramatic. Premium models can cost 20, 40, or even 60 times more than, I mean, in terms of the token per million cost than smaller models. So even when you use the most expensive model for simple tasks, you are paying premium prices for commodity work. A good AI system should route the tasks intelligently. Simple tasks should go to the low-cost models, complex reasoning, coding, multi-step planning, or sensitive tasks should go to the stronger models. This is what I mean by saying smart model routing. It's not always about choosing the cheapest model. It's always about choosing the right model for the right task. Understand the semantics of what the user wants. Figure out the best model for it in terms of cost and efficiency. Send it to that model. When it is done well, you can actually reduce the cost significantly without reducing output quality also. But model choice only helps if you can actually see the usage. And many organizations have another problem, which is shadow AI. Even if the organization mandates these models can be used, these LLMs can be used, but people often use personal accounts. And in those personal accounts, they can use official data also. That is the shadow AI problem. In this slide, we discussed shadow AI and unmanaged keys. Shadow AI is the AI usage happening outside your approved systems. This can happen when employees use personal accounts, as I said, unmanaged API keys, because when you're building or vibe coding, you can straight away use API keys, side projects, browser tools, or even experimental workflows. If you're using N8N, adding a module as GPT, connecting it, or even now you can use, I think, make.com, Zapier to just build the workflows. The issue is not always malicious. In many cases, people are just simply trying to move fast. A developer wants to test something. I mean, the team wants to build a prototype for a problem they are having. Someone signs up with a personal account and creates a separate API key. From the organization's governance perspective, this creates a major blind spot. Now, finance may see a charge, but engineering cannot answer where it came from. Security cannot see where the data was sent. A lot of different issues, interdepartmental, start occurring. Now, leadership actually cannot tell at all which team is using which model, because at the end of it, you might want that leverage of using multiple types of LLMs, which are good at different tasks in terms of reasoning or deep thinking. Then you want to pick up the best results. So you might, or every organization might want to use multiple LLMs and also understand which team is using what is the kind of usage, what is the kind of versions of the models that are being used, and what is the kind of charging which is happening. Now, as in the parallel world, I would say non-AI world also, attribution is very important. Unless you are able to attribute who used what, how much, when, you can't monitor it. So observability is very important, and governance is also very important. But in the case of observability, you just basically see the final bill. And shadow AI increases the risk beyond cost. I mean, sensitive data can be sent to tools without approval. API keys, suddenly I've seen this. It becomes a copy-paste thing. It goes to Slack, it goes to Teams, it goes to WhatsApp also. Now, usage can grow without budgets or rate limits. That's why you need to have central governance, central visibility. Every AI call must be logged. It must be attributed for the source, or it should be auditable. You should be able to answer, I mean, who made the request, or which app you built made the request. The app was made by the sales team or the marketing team, because anybody can make an app, or the engineering team. Even the HR team, they are making apps. Which model was used? How many tokens were consumed? Did it follow the policy which we have in-house? So this central visibility, along with, I would say, observability, along with governance, is very important. Because if you only see the Stripe charge, you don't have observability. You just have a receipt with you that you paid this. Right? Now, to understand why these costs spiral, we can talk about, there are essentially 5 levers which actually control the LLM spend in the slide. So the 5 levers which actually control the LLM spend. You don't tell the engineers to stop building. Don't slow any project. You just need the right set of controls in the right place as a context. So the 5 levers, the first one is smart model routing, as I explained, making sure each task uses the right model. Second is prompt caching. So you don't pay repeatedly full price, same system prompt or repeated context. And some of you may be engineers, so you already know the concept of caching, where you kind of cache it in the CDN, or you cache it at your end, or memcache, or so that you don't reserve the same data and optimize the compute. Similarly, you cache the prompts. Now, the third is per user and per team budgets. So spend has got a very clear ownership, that which user, which team in the organization is spending, and what are the limits to spend. And I would add one more thing here, is that you can add your budget controls with respect to the models also. For example, on Claude, we'll spend only this much, because there is this concept of token max. Now that into building something, right, go to max tokens, and when you are maxing tokens on a pre-model, you are spending a crazy amount, and only you say that the usage limit is reached, buy enough extra credits or upgrade your model. Right, so you need to have a model-based control, user-based control, team-based controls. And the fourth is context window discipline. You reduce unnecessary input tokens by sending only the context which matters. In addition, you should always also have a tokenizer kind of a system which removes the junk data from the input tokens which are not needed. For example, a lot of spaces are there, a lot of braces are there, which might not make sense. So if you apply a tokenizer, it will compress the prompt, the whole system prompt or the user prompt to only what is needed to be understood by the LLM. And the fifth is agentic circuit breakers. So making sure autonomous agents cannot loop forever or exceed the cost thresholds. Now, together, these 5 levers give you a practical framework for AI cost governance. Now, they help teams reduce waste, improve visibility, of course, when you're looking at a dashboard and understanding what is in front of you, and preventing runaway usage while still allowing the engineers to move quickly. I mean, the goal is not to create friction because everybody is building it. It's just to create guardrails. Now, I'll just take the 5. The first one is smart model routing. I had given a brief to you earlier. Now, as I said, right, I mean, yes, no decisions, extraction, rewriting, cheaper models like Mini, the GPT-4 or Mini, Gemini Flash, or even DeepSeek or Quen. One of those other work. Now, some of the tasks are complex. For example, deep research. You want to do a research, you want to prepare a multi-step process, any high-stake decision or advanced planning. They may require stronger models. You can use Cloud Opus, Gemini Pro, 5.5. Now, the mistake many teams actually make, as I said, is using the premium model, and it becomes a default, and then you basically keep it. Feel safe that I'm sure that whatever I give to this model, my is going to be better. That fascination, or I say love for that model makes it very safe. A better approach: define a routing policy at a gateway level. The gateway can decide which model should handle based on the app, based on the user, complexity, efficiency, everything. Now, support ticket classification, for example, go to a Mini, 40 times cheaper. So now trying to classify 50,000 samples, say, per month, it could be $2,500, kind of saving quite a bit of money. There's a huge difference for a task where the user may not even notice a quality difference. The answer from a 5.5 or a Mini would be the same. A smart routing can turn, basically model selection developer by developer decision from a centralized policy. So you have a policy that controls it. Then the developer the policy in the routing automatically takes care of which model is the best for you. Now, the second lever is prompt caching to avoid paying full price for repeated tokens. Now, I mean, without caching, if you don't do caching, you pay for the repeated tokens every time. As I said, the same instructions, the same policies, the same formatting rules. Keep it. Now, providers like Anthropic, OpenAI, and Google, they also support forms of caching, and the repeated tokens can actually become dramatically cheap. In some cases, almost 90% cheaper. Now, especially very useful for applications with long system prompts, stable sets, repeated templates, or maybe if you have a common knowledge base, you can leverage that. But the key point is where the caching is implemented. Now, you need to have the caching implemented before it goes to the models. Now, if every app has to configure your own caching separately, some teams will do it, some others will forget. Some others will not even know whether they have to implement prompt caching, and you can't do that because that has to be built. Now this will create inconsistency. You might have some savings somewhere, but you might not have it. Now, the better approach is again have a gateway layer where this prompt caching is implemented. So every just kind of communicate to the gateway. Benefits of your best engineers to configure a single app platform handles it centrally. It is powerful in reducing costs for you without changing your user experience. The application exactly the same way, repeated token costs have gone lower. It is, I would say, it is one of the things to actually free money in LLM cost optimization. just being a little. Now the lever talk about basically budgets, because everything needs clear cost contracts. Now, in traditional, you know how many seats you have bought. In cloud infrastructure, you can set budgets for compute or storage. Take your 1 terabyte disk, or my computers are taking only a 8 GB machine. And defining, you can, based on the user behavior or the needs, and the most key thing about AI apps and is that the more it delivers for you, the more
Excuse me,
you
Deeps,
get to build.
your voice is breaking.
Okay.
You can just switch
All
on
right.
and switch your mic and then start again.
Okay. Is it better? Is it better?
No, not yet.
Okay, I will get a little closer. I have unmuted and muted.
Okay, yeah, go on.
Unmuted again. Yeah. All right. Okay. All right. So I was just talking about your SaaS example. So in the SaaS example, as I said, right, you know the seats, you know the budgets, but where you try and kind of always get it by building more and more functionalities to achieve more. The budgets need granular and more controllable. Important thing here is that you need alerts. You need alerts in real. You don't want to discover the problem after the invoice arrives. So you want alerts at 50%, 75%, 90% of the usage. I know that OpenAI and some of the other models in their platform configuration also allow you to set up the thresholds and stuff, but again, it is managed very differently, and you are only managing it at a model level. So you need to remember it to manage at the model level. You cannot, and at the model level also, you can't manage it per team or per user, per version. You do that. It's a alert you can buy. Now, in some cases, you may want hard limits. If an app exceeds the approved token budget, the system can downgrade the model, pause requests, require approval. I mean, you could plan a lot of things, especially important for agents. If you accidentally run a recursive agent on a production key, a hard budget can prevent a small mistake from becoming a major incident. And also, when teams have clear budgets, they also become more accountable. They can see their own usage. They can understand their own cost drivers. This app with this kind of an app, this is a is kind of increasing the cost. They can make better engineering decisions. So budgets are always proactive, pre. So you need to be enforce the AI budget before the bill arrives, not after. Explain it after that. And the last two levers are essentially talking about the context, discipline, and certificates. So context discipline, as I said, is one of the highest impact engineering changes most teams can stop sending unnecessary context, reduce the cost and latency, summarize your RAG chunks, summarize your older terms, use 5 terms instead of use 8 high quality chunks instead of 80 chunks. You can put token cost by 60 to 80%. So imagine caching, context discipline, along with budget control, observability. You're actually controlling the cost, optimizing the cost without affecting the coming back from there. These are useful individually also, and they become very powerful post architecture. So the decision is not decentralized because multiple people are making apps. They are making apps. You are out, you are working somewhere, and now there are which provide agents also. You might pick agents from there also. You can't control, you can't implement all policies at places in a decentralized way. It has to be in a centralized way. Now, the right governance structure, many teams start by adding cost control inside individual apps. As I said, some apps have logging, some have no control at all. This approach does not scale. And that is where we talk about a gateway layer as a better architecture. The gateway sits between your application and the model provider. Instead of calling OpenAI and Anthropic, Google, or other providers directly, the app route the request through the gateway. This gateway becomes the central control plane for AI usage. Now, policy change can apply to every app. Every call can be logged. Every request can be attributed to a user, team, application, model, or cost. Budgets can be enforced centrally. Prompt caching can be applied consistently. Smart routing can happen. Circuit breakers you can apply automatically at a gateway layer. And the developers don't need to change their entire stack. I mean, they can keep existing frameworks and just swap the base URL. The engage with the gateway is exactly the way they engage with the LLMs directly. So that's the pattern becomes very powerful. And that is where I would like to introduce Konsole. I mean, in Konsole, we have talked about essentially taming runaway AI spending and about the 5 levers which we mentioned about. Now, this is exactly where Konsole comes into picture. It is that gateway layer. It is a gateway which provides you the 5 levers: the routing, the prompt caching, the budget, the circuit breakers, spend alerts, audit logs. So it works on exactly the OpenAI endpoint pattern. So if you have built apps which are you OpenAI, you can replace the endpoint, the URL. Everything else remains the same, and suddenly you get the entire gateway power with you. It will do intelligent caching, it will prompt optimization, it will do smart model routing. Everything is built into the gateway. You get full visibility. You get actually a dashboard for the organization.
Yeah. I'm sorry to interrupt. We are quickly shift to another internet. So please give us 5 seconds and then we'll begin. Deeps, you can begin now.
Hello, is it any better, Ankita?
Yeah, you can begin now.
All right. So I'll just take a couple of steps back where I was talking about Konsole. I'm not sure if you did not hear the previous one, but I'll cover it up. So when I talk about Konsole, we spoke about a gateway layer which interacts with multiple apps on one side and LLM providers on the other side. It provides all the 5 levers which are needed for essentially optimizing your cost when you are leveraging LLMs. The first one, as I said, model routing. So smart model routing, where you are understanding the intent of the user and routing it to the correct LLM provider based on cost, based on efficiency. Then second is prompt caching. So you leverage prompt caching, which the LLM providers provide, but at the gateway layer, so that you are able to maximize the advantage. Budgets. So you open up central visibility, central observability, and so that you understand where the budgets are going. You can control the budgets per team, per user in the organization. In fact, per model version also. Then you introduce circuit breakers. So there are thresholds that if a budget crosses a certain threshold, you are able to kind of apply a kill switch right there, so that there is no runaway spending by any of the agent which is misconfigured. You set up alerts, so you know upfront that which version, right, from which model, from which user is giving you what kind of usage. So you are able to design better, engineer better. And audit log, so at the end of it, you can actually see very clearly what actually transpired when you, in this month, when you used 10 apps or 20 apps across 5 models and took the best advantage what you had. So this way you can take advantage of all the models to the maximum without spending or without unnecessary spending or any inefficiency built in, along with full control. Now, the other thing here is also PII masking. So which prevents the problem of shadow AI. When you are using all these LLM providers, you might be uploading your internal company documents, you might be uploading documents which might have name, email addresses, any personal information available. You can, in the dashboard, you can define what is PII for you in your organization. And there is a PII library which Konsole supports automatically, which is like the PAN number or the SSN, the names, the phone numbers, emails. All this information is masked before it goes to the LLMs. So you can freely upload whatever documents you want and get the answers you want from the LLMs without compromising on sending any personal information to any of the providers. This gives you a total control, full visibility, observability, governance, alerts, everything together. And the other thing is, the fourth thing I would say, it also supports bring your own keys. So in Konsole, you can use your own keys from all the models when you are building your apps. And these keys are all hardware vaulted. So these keys are not visible to your developers anymore. It's only with the gateway and stored. Developers get basically a token to work with. So you can have as many developers build as many agents and applications without knowing any of the keys. So nobody has access to any of the actual keys, which probably only your management would have access to those keys, and they are all configured and hard vaulted. So that way, your the copy paste of keys here and there without the environment also is not there. So you're not vulnerable on security as well. And the integration is actually fundamentally designed to be simple. You can just swap the base URL instead of OpenAI, use Konsole. Everything else remains the same. The parameter structure, the whole URL construct, the completions API, everything which OpenAI provides, it's exactly in the same format. So nothing changes. Your apps do not have to change. So Konsole doesn't replace your AI stack. It is basically a control layer you act, place it in the middle so that your AI stack is more visible, governable, and cost efficient. So suddenly your AI becomes, from a black box, it becomes a managed system. Now what I can say is that if you're wondering where to start, here are the 5 things you can do. You can you can audit your model usage, you can do enable this prompt caching, all of this you can do. Now what we offer is that you can start free with Konsole. You don't need to apply your card or have an account with Konsole. Just create an account. If you are a developer, take a developer plan, understand how to build an app, build a sample app, see the governance, see the observability, what are you getting, see the power you suddenly get on your AI usage and on all your models. You get access to all the top frontier models, all their versions right through Konsole. If you have your keys, you can apply your keys and leverage it. If you don't have the keys, you test it with the current stack, test with the free models, understand where the spend is actually going. You might get a lot of interesting data to understand that, hey, this is where my agent is spending, or this is where my app is spending. It might give you a lot of other information. Konsole also provides a chat room, which you can use exactly the same way you chat with GPT or any other model. It gives a multi-mode model chat room where you can interact with a model with PII safety and all security inbuilt. You can take opinions on an answer from GPT from Claude. So if GPT has answered you something, there is an option you can take an opinion, second opinion from another model. You can take opinions from multiple models altogether and understand that, okay, this is what I wanted to know. What does Claude say? What does GPT say? What does Gemini say? And then you can decide what is best for you. All this in one shot and one prompt, with the tokenizer, with prompt caching, with circuit breakers, budget control, everything inbuilt. So you can visit Konsole.one to start free. You can sign up there also, or you can reach out to any of us to the Konsole team to book a detailed demo if you want. We could do that and give you the best experience in terms of what a gateway can give you and help you tame and have total control on your AI spending. So, and this is what I had. Thank you everyone for joining. If there are any questions, I'll take it. If there is one takeaway, I would say you cannot control AI spend only after the bill arrives. Have all these 5 levers, visibility, governance, and circuit breakers in place. where the AI calls happen, and you'll be innovative as well as safe. Thank you.
Thank you so much, Jeeves, for such an insightful presentation. Now we would love to open the floor for questions. So, Deeps, we have our first question. From your experience working with customers, what's the biggest blind spot organizations have when it comes to AI spending?
Yeah, I think the biggest blind spot is, I would say, clear observability. So unless you have observability, you cannot take decisions. So once you have good observability into the spends, into which model is being used, the usage, which team is using, role-based controls. Once you have that observability, you can start applying the circuit breakers and cost control, and arrive this at the same results, same quality from those models, which you would otherwise spend much more on. So that is the biggest blind spot, observability. Yeah, I can see quite a few folks. I can see Jay, Ankit, Saurabh, Shobha. So please go ahead and ask any questions if you have.
There's another question. What's one lesson you have learned from helping companies manage AI costs that isn't usually covered in webinars or best practice guides?
One lesson.
You have learned from helping companies manage AI costs that that isn't covered in any of the webinars or best practice guides.
Okay. I think that one lesson from the companies who have been who manage the AI costs is that I think they have clear responsibility. And the first thing what they do is setting up of policies with respect to AI. That now there are two types of usage. One is a typical chat usage where the employees engage, and the other is the application usage where the internal company builds apps and agents. So one clear thing is whosoever is managing these AI costs better is having a very clear centralized policy on both of them. And either they are manually managing the centralized policies and enforcing a weekly review, or they are using a gateway layer in between, which can help them do it automatically. Yeah, I can see one question from Shobha. So how is Console getting integrated to enterprise LLMs? So yeah, so Shobha, we have an adapter framework. Now this Console already integrates to all the top frontier models at the moment, right from OpenAI, Anthropic, Google, DeepSeek, Alibaba, all of them. We integrate all already. Now, if there are any custom LLMs or SLMs by the enterprise which they have of their own, then we have an adapter framework by which tool can connect with the LLM endpoints and induct it into the system and make it available in the panel. So it's I think less than a day activity where If there are custom LLMs, they can be integrated right away. But if it is any of the frontier models which already exist, they are already available.
Deeps, we have another question. As AI adoption accelerates, do you think organizations should focus first on reducing costs or on establishing governance, which creates the bigger long-term impact?
Yeah, I think establishing governance comes first. That automatically helps you focus, increase your focus on reducing the cost. Without governance, you are playing blind. So you are, as Shobha also asked, right, enterprise LLMs. In enterprise LLMs, even if it, whichever type of LLM it is, unless you have governance over it, you should not induct it. When you are inducting it, first establish governance, have visibility to the right people, to the right teams, and then cost reduction is a consequence of governance.
Okay, so that's a wrap on today's session. Thank you all so much.
Ankita, just 1 second. I think I have one more question from Shobha. How secure is Konsole itself? Can you share any security privacy measures the product? Yes. Very good question, Shobha. Thank you for that. So the way we have built Konsole is essentially there are a few important things Konsole considers, which is I mentioned in the presentation also hardware vaulting of API keys. So this is hardware vaulted and encrypted, so that is not accessible by anyone. No developer gets access to a key. They only get access to temporary ephemeral tokens. The second thing is we have a hardware attestation and enclave built in. So whenever there is a conversation which happens between the app and console, or between through the chat room, a user is talking to console, every session is encrypted differently. And that way what happens is even if there is a man in the middle attack by kind of trying to understand what the user has typed or what the app has typed, it will not be able to interpret it, or it will not be able to map the origin back. So there is hardware attestation, there is hardware enclaving, there is hardware vaulting also in place. And we take care of almost 17 types of agentic attacks at the moment, which can happen with the LLMs. So any malicious agent trying to misbehave with your LLM on your keys is not possible. We catch it up front itself. We have a data brief of all the security measures also, which we have taken. So if you can drop in your email ID, we can send off the data brief to you.
There's a last question from Shobha. Is this a SaaS solution, or is there an on-prem version as well?
Yeah, we have both the configurations. So this is available as a SaaS also, and available as an on-premise solution also, which can be air-gapped into your office. And you can kind of have a very private on-prem thing for your organizations. Your organization may have X number of users. So based on that, you can deploy a console in the box solution in your office.
So that's a wrap on today's session. Thank you all so much for joining us and for the great questions. A huge thanks to Deeps for walking us through the cost and security side of LLM and agentic AI access. So if you would like to learn more about Console or want a closer look at how it could fit into your team's workflow, our team will be following up to you very shortly. So thanks again for your time today, and we'll see you at the next one. Thank you.
Sure. Thank you, everyone. Bye.